Welcome to the lecture videos on Chapter 21. And Chapter 21 really covers two fairly different topics because Chapter 21 is the transition point in the course. So we're going to wrap up our discussion of electric and magnetic stuff. And we're going to do that by first talking about the kind of most complex and most sophisticated circuitry we're going to talk about in this course. And then what we're going to talk about is something called Maxwell's equations, and the book refers to them as Maxwell's predictions, but they're generally known as Maxwell's equations, and show how this relates to light, and talk a lot about electromagnetic waves. This is the transition into our discussion of light, and our discussion of light and how we bend it and how it reflects and how we use those facts to make lenses and mirrors and how we use those mirrors to correct vision and you see microscopes and see with telescopes and so on. That's the rest of this chapter this course. So really this is the halfway through this chapter is essentially where we transition from a bunch of discussion about electric fields and magnetic fields, tie it all together, talk about the most complex applications for them, and then sort of lead into a discussion of our next topic. So one is that there's a lot of content in this chapter. This is just a very long chapter overall. The other thing is that this is probably one of the most difficult chapters in terms of content because it ties together many different elements we've talked about so far, and it also essentially has everything's been building up to this point in our discussion of circuitry. So we're going to have the most advanced circuitry discussion, and we're going to talk about all these other concepts like magnetic fields and electric fields as thoroughly as possible. Just a word of warning, you may want to spend a little extra additional time trying to reviewing this material, working through it, because it does take a little extra to process it. So I want to go over a little bit in detail about the general topics we're going to go over. So the circuitry stuff is all going to be related to alternating current. So alternating current is what, when I ever say AC, that stands for alternating current. We've so far been talking about something called DC, direct current. So all of our circuit stuff we talked about is DC. We're now going to introduce this concept of AC. We'll talk about what alternating current is. We'll talk about how you describe alternating current, and we'll talk about all of these how these circuit elements we talked about before, resistors, capacitors, inductors. How do these behave in the case in the case where you have an alternating current? Now, the basic idea of alternating current is that it continuously changes over time. And that makes it a little bit more tricky to understand because there's a time dependence that's not found in direct current circuits. Now, the phrasing I have here is a little bit different on how I'll actually go through the chapter. I'll talk about how do resistors behave with AC, how does capacitors behave with AC, how do inductors behave in AC, and then I'll talk about what happens if you have combinations of resistors, capacitors, and inductors. And you have a couple of, and that's an RLC circuits, which means resistors, a capacitor, and a inductor, all hooked up in parallel, all hooked up in series with each other, is one of the most difficult circuits we will describe in this. And there's some really interesting behavior. We'll talk about things called impedance and reactance, which are like resistance but not quite resistance. We'll talk about how this leads to something called resonance. So we'll talk about resonance in these circuits, and we'll talk about the power. So how much energy is being dropped into that resistor every second. We'll also end with a note about transformers, which are important to actually understanding how our power system works, and we'll talk briefly about it. It relates to inductors and something called mutual inductance, which is a slightly more sophisticated version of inductance. And that'll end our circuitry discussion. Then we begin with Maxwell's equations, which are the general rules for how does charge and current and anything else produce electric and magnetic fields. And there's essentially four rules encoded in four equations that relate the fields to the things that cause the fields. And we'll show that this leads to a type of a wave. And we'll discuss how this wave is a good model for what light is. And we'll talk about the properties of these waves.